All right, great. Ready? This is, we are going to continue with today we are going to talk about the wiring of the AC panel and the procedure to wire the AC panel. Yesterday we explained the function of the galvanic isolator, and now we are going to talk about the isolator transformer. You remember the video? What is the function of the isolator transformer?
To clean the current.
Clean the signal, the AC signal. You remember that the AC signal originally is this type of signal, no?
Yeah.
But the signal, depending the environment outside, the signal coming from FPL, depending of the ground of the transformer in front of your home, depending of different factors, the signal is not completely clean. The signal coming is like this. You know? It's like this. This is the signal that if we connect an oscilloscope to the outlets, that signal is not completely clean. Why? Because different reasons. No, because normally it's bad ground, and you have too much noise, too much interference. That signal, for example, in hospitals, for example, in universities, for example, in financial companies like banks, that signal is not good for computers. No. For example, you remember you work in Motorola, no? Yeah. The noise interference is the enemy of all of those. What is the procedure to clean those signals? The isolator transformer. But let me explain what is the meaning of isolator transformer. Suppose that I have a mirror here in front of me. Oh, I have other Lopez over there. That Lopez is clean. That Lopez is no high blood pressure. No, it's clean. It's perfect. This Lopez have a lot of problems, but the other one is clean. Is the Lopez of the mirror. You remember yesterday I said you have a coil here with power, and you have in front of them other coil. The current pass through the other one? Only because it's pretty close? Yes or no? No. Yes! What is the name of that process? Induction. For induction, the electrons jump into the other side. Only for induction. If I have one coil pretty close to the other one, the current pass to the other one. But the other current in the mirror is completely clean because it's a mirror. Oh yeah, if I pass that one for that current contaminated enter in the first coil of the transformer, what happened with the coil in the second coil? With the current in the second coil, it's completely clean. That's the input coil, and this is the output coil. Is perfect, it's clean. All right. If you remember yesterday, what happened if in a transformer, the first coil is with 100 turns, and the second coil is with 50 coils. How much is the voltage in the output? Half. If the input is 100 coils and the output is 200 turns, how much is the voltage? Double. You have a step up transformer or step down. What happens if the coil at the input and the coil at the output are the same amount of coils? Only clean. And the name of the transformer is isolator transformer. Isolator transformer is when both coils have the same amount of turns. Ready? And both coils are exactly the same. We have one more chair here, another one over there, if you want it. One and one. And three. We have four. All right. Yeah? That's the difference between step down, step up, and isolator. Okay, what is the function of the isolator transformer? Clean the signal. You know how important is clean the signal in a hospital? You know those expensive chirurgical robotics equipment, what happens if the signal is erratic in the surgery? That's catastrophic, no? For that reason, at the input of the hospital, you see huge isolator transformers, only to clean the signal coming from FPL. All right, the same in banks. In a special company, they need clean signal. Why in your boat is critical if you have a mega yacht, super expensive, with a lot of toys, a lot of electronic devices, is important a clean signal?
Yeah.
Oh, papi. Yeah, yeah. You know the price of each element in those expensive boats? The isolator transformer is important. The isolator transformer is completely different than the galvanic isolator. This is only to block intrusion of bad currents, correct? To protect from corrosion. And the other one is only to clean the signal. If I have a medium boat, 45 feet, 50 feet, probably I don't need isolator transformer because I don't have sophisticated equipment. But if you have a mega yacht, yes. And in the future, you will be working with different type of boats. Oh, in this boat, I have isolator transformer. Okay.
Why is it that is DC already clean?
Excuse me?
DC currents already clean?
Yeah, the DC currents are clean because the DC currents no change the polarity. It's a straight signal. It's clean. It's clean.
So this actually blocks DC current too, right?
Excuse me, this is only AC current.
Right, but it blocks any type of DC interference.
Black?
No,
There shouldn't be nothing
No,
out there.
no.
Because if there was a DC, anything connected would wipe out the DC side.
No, this is exclusive for AC. In DC, you don't need clean the signal. You don't need, no, you don't need clean the signal because it's clean always.
So with the step up and step down, are they called step up isolator transformers?
No,
Or
a
is
step up transformer, a step down transformer, and the other one, isolator transformer. The isolator transformer only clean signal. That's it. Only clean the signal. Okay, pay attention, because this is one important thing. Danny, can you close up the board, the screen on the wall,
Close it up.
All right, look at this. In ABYC recommend. Thank you, Dan. ABYC recommend install the isolator transformer here. The isolator transformer here, and I say no. This is not good. Follow me, my friend, because this is important. ABYC recommend install the isolator transformer here only to clean the signal coming from
shore power?
the shore power, the pedestal. And I say, no, my friend, you are wrong. Because what happens if you have in your boat an old generator with the back end with a lot of dirt, humidity, like the generator that you have? That generator, 100% sure, you start that generator, we connect the oscilloscope, and the signal is completely contaminated. The same if you have an old inverter with too much humidity in the winding and in the circuit board. For that reason, I put the isolator transformer here to clean the signal from the inverter, to clean the signal from the generator, to clean the signal from the shore power. I locate here. All right? When I do wiring in different boats, I install the transformer over there, not here. Because with this, you only clean the signal of this.
Is that an ABYC question?
The ABYC question is, where should be located the isolator transformer? And in the option they say, in between the pedestal and the shore power and the switch selector. In between that, and they say that the proper answer is this. I recommend install here, after the switch selector, in between the switch selector and the main panel, the main AC panel. Is clear?
Yes.
You have question? You understand why I recommend here, not here? Because with this you only clean that one. But what happens if I have an old generator? The old generator produces contaminated signals. If the winding, you remember the winding yesterday in the rotor and in the stator? If you have too much humidity, dirt, the signal is contaminated.
Could there be multiple?
No, it's not necessary. No, you can, but you can. But those transformers are expensive.
Yeah, I was gonna say, those things are expensive.
The small one that we have on the shop, the small one is $1,500. It's for single phase. It's too expensive. Right.
Does the isolator transformer also help with frequency, change frequency?
No. This is a good question. In the chapter 15 or 14 of your book, we are going to learn the procedure to calculate transformers. Let me show to you quick.
What is that?
Yeah, that one.
Oh, this is
The steady guy.
yeah, this is for our certification for the
See?
NYPC.
Oh, yeah. Okay. I gotta get one.
Yeah, it's for the certifications test that we have to take.
Where you going?
It's something else. It doesn't go through Broward. And this is his, like, course Broward.
Every kid
Mire, guys, you have in your book, we are going to talk later about that. It's only to clarify for Yoli. Yoli says, oh, with the step-up transformer or a step-down transformer, can I increase or reduce the frequency?
No.
The answer is no, only the voltage. Only the voltage. We are going to study later one magic formula. But if you want, I am going to demonstrate the formula because I love it, the formula. Right now, what happens in a transformer, my friends? What happens if in a transformer?
You're stuck up or stuck down?
Doesn't matter. Suppose that this is the input 120, 100 turns, and the output is with 50 turns. How much will be the voltage? Is 60 volts, because I have half turns. All right. The formula is this. What is the secret in a transformer? What happened with the power at the input with respect to the power in the output? The power in the output should be higher or lower than with respect to the input power? Or should be the same?
Lower voltage.
Always the same. Doesn't matter if the output voltage is higher or lower, the power should be the same, because the energy is the same. If not, you are creating energy and you are a god. Oh, papi, you create energy. No? The power should be the same. Oh, if you increase the power, Bill Gates is nothing in comparison with you, because you create power. Oh, wow. No, the power should be the same. What is the meaning of that? The power at the input should be equal to the power at the output. What is the power at the input? Voltage in the primary times intensity in the primary. Yes or not?
Yeah.
Should be equal to the voltage in the secondary times intensity in the secondary. With this magic formula, voltage in the primary divided into the voltage of the secondary should be equal to the intensity of the secondary divided by the intensity in the primary. With this formula, you calculate the rest. I have this and this and this, I discover this. Oh, I have this and this, I discover, yeah? Depending what you have, this is the magic formula. Voltage at the input divided by the voltage at the output is equal to the number of coils in the primary divided, yeah? This is the magic formula only because the power is constant. The next one, Danny. Look at this one, you see? This is the formula. If the power is equal, voltage times intensity should be equal to the voltage times intensity, and you have that one, exactly that one, and with that formula you can calculate the rest, but this is in other chapter. We are going to play with this. But the intensity cannot be increased or decreased with the step up or step down transformer. What is the only way to increase or decrease frequency?
Just
On the
up,
RPMs. On the RPMs. If my engine is an all engine gasoline with carburetor, in the throttle valve, no, on the throttle body. If my engine is injected, where you increase or decrease?
On the side of the fuel injection.
Yeah, exactly. All right. Later we are going to talk about that. But
It's injected,
frequency can be modified only with RPMs. More RPMs or less RPMs. That's clear, my friends?
Yes.
Ready? We are going to come back to. We are going to come back to this. You have all of the information in your book. Okay. Now we are going to play with the wiring of the AC panel. It's clear the difference between isolator transformer, the difference between galvanic isolator. Yoli, the majority of the people say, oh, my boat is protected because I have isolator transformer. My boat is protected for corrosion with my isolator transformer. This is true? No. The only way to protect your boat is with a galvanic isolator. The other one is to clean the signal. Can I wire a boat? Can I use all the equipments, electronic and electrical devices without isolator transformer?
No.
Is necessary is mandatory the isolator transformer in a boat? No. 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 Okay? But is mandatory, is necessary the galvanic isolator? Yes. 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 It's critical in comparison with the other one. They are similar? No. Nothing. Not similar. One depends on the other one? No. They are completely independent.
So one had a question that they asked in the group chat. I don't know if you answered it, but the anchor chain is protected how?
The anchor,
Oh, you're the one that sent me that, yeah.
later we are going to talk about that.
The witness still needs to be bonded no matter what. If it's
All the metals,
Yeah.
all the metals should be bonded. The anchor chain, Mr. Lopez, is over there in that corner. I have pictures during the storm. The strike touched the anchor and destroyed the pulpit and the fiberglass because was not connected to the bonding to drain the current.
Where do you connect it?
Oh, it's simple. Danny, can you explain?
On the anchor itself, it's actually the unit itself. The actual wings will be bonded.
Oh, that's it.
It's impossible if it's all rope, it's impossible to bond the anchor.
Yeah.
And you can only bond the windlass itself, even if it's chained. What do you do? Put a wire as long as the chain, you can't do it, you know. Now, if it's all chained, normally that chain will attach to something inside where the anchor locker is. You can bond that in there. But if it's rope,
Oh, so where you know how you put it on the bridle? You know how you put the chain on the bridle?
Yeah.
But the slack chain sits on top in like a little.
yeah, when those are
And
through
it's
bolted,
right there.
you put a bonding underneath the through bolt.
Yeah.
Everything has to be bonded.
Chain.
Yeah, the chain,
Yeah.
where the chain sits on
Yeah,
the
where
on
the
the
chain
cradle.
sits on that
Yes,
thing.
underneath when you install
Yeah.
that, you should have the through bolt and you put.
Some people say, oh, I have a metallic cabinet in my boat, but it's over there. It's over the water line. Is necessary connect that metallic cabinet to the bonding system?
Yeah.
Yes. Yes.
How would you do that? Put a screw into the case?
Single
and
wire.
then,
Yeah, in the case. And a screw, the cable, later we are going to learn what is the gauge of the wire for bonding.
4 gauge.
No, it's number 8. Number 8.
6 is the one that goes to the.
6 is for the lining protection. You remember that cable? The other one is 8. Okay.
I've been hit by lightning before out in a boat up there. It's not, but it doesn't but the boat protects the boat. Nothing happens to the boat.
No.
That's if it's
well,
wired.
if it's
right?
wired,
Yeah,
Okay, guys, we are going to start with the wiring of the boat. We are going to put enough here for a little. That's not. Okay, guys. We are going to explain the procedure to wire a boat single phase, and after that double phase. And we are going to explain the procedure to wire above with the switch selector, generator, inverter, short power like this, or with three breakers. One breaker for generator, other breaker for short power, other breaker for inverter, and we are going to explain the procedure to connect in the back all of those breakers. Good?
Yeah.
All right. And we are going to explain the procedure to connect the voltmeter and the ammeter in AC. It's a little different than DC. And we are going to explain the procedure to connect the frequency gauge, because right now we have frequency, and we want to know if the frequency is higher or lower. No?
Yeah.
Because you have a generator and you need to know what happened with the frequency in your boat. What is the symptom when you have you are suspicious that you have problems with the frequency in your boat?
Oh, the light flickering?
Oh, the light flickering. Or you touch the freshwater pump, suppose that it's a big boat and the freshwater pump is AC, and you touch the pump and the pump is too hot. And you say, yes, now the pump is too hot, but when the boat is connected to the shore power, the pump is, and the lights are not blinking. What is the meaning of that? The frequency of the generator is different than the frequency of the pedestal. Because when the boat is connected to the pedestal, everything is perfect. Lights perfect, when I disconnect the shore power, start the generator, okay, everything is running, but too hot and the lights, this is frequency. This is the symptom. I'm going to explain the procedure to calibrate that. Okay, good?
Yep.
Mr. Lopez, what also, like when you have a freshwater pump, if you have a VFD, it's not going to be hot, right?
Yeah, but
What is it?
we have two options: freshwater pump DC, 12 volts or 24, or we have a freshwater pump AC, single phase, double phase, or three phase. And we are going to learn what is the advantage of a single, double, or three phase. For what reason is better double phase or three phase in comparison with single phase. Okay? All right, we are going to start with the first one. This is the pedestal. You remember that the pedestal have a 3 board, no? 4, really. 1 to receive. Hat 1, hat 2, neutral and ground, no? Hat 1, phase 1, doesn't matter, or red, no? The phase 2, the other one neutral, and the other one ground. Those are coming from the main transformer on the dock. You remember? And the main transformer on the dock receives the power from that transformer on the street. Anybody follow me? Pin, and pin. Okay. Now this is my pedestal. And this is my boat. And what is this? What is this? This plug, no? Is this? Ready? The AC outlet?
Yeah, it's the inlet. Actually, it's the inlet.
Sorry, inlet. And this one is the shore power connected here, no? That's the shore power.
That's the outlet.
Ready?
Is there any risk when you're connecting the
Yeah, I'm going to explain the recommendation.
Very careful.
Be careful if the piece, the ground is wet. Yeah, I'm going to talk about
If
it.
you notice, sometimes you'll see like some people put a board.
A piece of wood, and I have another recommendation. Only because you are my friend.
Where are boots on?
You remember that yesterday we explained that the hot and the neutral are the beginning and the end of the coil, no? hot and neutral. This is the beginning, coil, and this is the end. And you remember what is the function of the neutral?
Just return the unused.
Return the excess of current into the ground, because at the source of the power, neutral and ground are together. Do you remember that? Okay. All right. For that reason, when you go into the pedestal, if it's raining, you know when you are in the traffic light and you see the power lines, you see the birds, and you see that something in some situations the bird is here like this, with one leg. Over there, you see? In some situations the bird is with both of them. Why the bird in some cases decide like this or decide like this?
Current.
Because the bird is intelligent, it's not stupid. When the bird is approximating to the cable with power, the bird feels the magnetic interference around the cable. You remember the EMI, electromagnetic interference. You remember when the current is moving, create a field around the wire. When the bird, feel, and the bird say, it's powered at the cable and enter only with one leg. What happens if the bird puts both legs? Close the loop and finito. Ay, mami! For that reason, my recommendation is raining, everything is wet, touch the cable with one leg. Ding, ding. Remove the cable, put on, and now you put the second one. For safety. All right, that's later. Okay.
Pedestals have
People are gonna see you with one leg. Like, what are you doing? My teacher told me.
Don't
The
fall
Lopez
in the
say.
water.
It's not the volts.
Yeah, Steve just made a point. It's not the voltage that kills you, it's the amps.
Yeah, and you don't need a lot of amps. It's with a
20 amps.
milliamps.
65. Wait, how many did you say?
All right.
Well, just put it this way, on the outboards or stern drive, the voltage coming out of the ignition coil is about 40,000 volts. That doesn't have a lot of amperage. So you'll get shocked, it'll hurt. It's not hurt bad. I mean, I get shocked all the time, but it's not something that's gonna knock you on your ass.
You talking about DC?
Yeah, the DC like on the engines, the ignition coil, even in your car. You touch the ignition, you get zapped, you're just gonna get shocked. It's not gonna kill you because there's no amperage behind it. It's just
The DC current is not lethal.
yeah.
AC.
And AC will put you on
So
the
you're
ground.
saying I should.
Why? Because the alternation. DC, no. For that reason, my friend, when you enter in a boat to replace batteries, to check DC, troubleshooting on DC, like this, touch the cable, no problem. No enter like this with it. No, papi. The customer have cameras today. What happens if the customer see a technician touching the battery like this?
This one like.
Finito. Finito.
When you get shocked, it won't be the first and it won't be the last. And the DC shocks, no.
Just get it over
The
with.
AC will, depending on the
Get
amperage.
it over with.
It's got-
Okay, follow me. We are going to do the wiring for single phase boat. Next, double phase. Ready? And we are going to do the first one with the switch selector. Inverter, generator, and short power, single phase. Single phase, guys. Short here, generator here, inverter here. And we are going, the inverter is located inside, but only for the picture, I am going to put this is the inverter. What is the input of the inverter, guys?
Batteries.
A group of batteries, no? DC. That's the input of the inverter. Negative and
Positive.
positive. And the positive have a switch selector. And in the output we have for single phase, hot, neutral, and ground. Okay, and at the same for the short power. This is single phase. This is the first connection.
Wait,
Sing-
Mr. Lopez, the ground doesn't go on the battery switch?
Yeah, it's from the body of the inverter or the body of the generator or the body of the transformer.
But does it go to the switch
It doesn't go to a switch.
Sorry, no, sorry. Yeah. This is only to verify if you pay attention. Yeah, sorry. Okay, and the same with this, from the breaker. And from the breaker, this is single phase. And this is the output. We are going to locate here that element. What is the name of this element? The transformer. And here we are going to locate. We are going to locate the main breaker. This is the first connection. It is single phase. Single phase. All right, and this is the output. Look at this. You see? That's the neutral, is the return. And what happened with the ground? Look, this is the frame. This is the, oh, sorry, no, yeah. And here is the same. Because this isolator transformer, what happened with the amount of coils? The amount of turns? Are the same, no?
It's just cleaning it, right?
It's only to clean. And this one here. And what about the ground here? Look at this. The ground is any part of the frame. The frame is in iron. In other words, the neutral and ground are together. And after that, this one, look, here you have ground. From this point you have ground. And the ground enter here, but the ground goes directly outside into the ground bus bar, and this element is connected here, or should be connected here if you want it. No problem. You see? That's ground. Okay, the galvanic isolator will be located here. The galvanic isolator. Ready? You interrupt the ground and you insert the galvanic isolator. Good? And this is the isolator transformer. Okay, great. And this is the switch selector. This is the switch selector, short power, generator, inverter, and this is the output. This is the output, this is input, and this is input. Right? Good? Okay, now we are going to install. Let me put the breakers in the other side. You remember that we have breakers, no? In this particular case, what happened with the breakers? The breakers are, all of them, single phase breakers, because I only have one phase, no? But, and this is neutral, and ground is here. And this is the main breaker. And one hot line is coming here to connect all the breakers. And in the output, for example, I am going to connect one fan. The fan is 120, okay. The hot line is coming here. Here is the neutral bus bar. Neutral. One cable is coming from neutral. And the other one is connected here. Is connected here to the ground. Yes or not? Oh, I want to connect a light. The connection is from here into the hot line, no positive, hot line. And this one for neutral, yeah, for the light. And the case of this element, the case of the light, the holder where the light is connected to the ground. Ready? We are going to do that in the board. And we can connect other equipment. This is an example. Okay, until this point. Difficult? This AC?
It needs a ground, so can you just do it to like the ground bus bar?
Yeah, you can connect here or here. It doesn't.
How many ground bus bars are there usually? As many as you
Yeah. If the recommendation, all of them together.
Mr. Lopez, can I take a picture?
Just
With
don't
me?
connect the negative on the AC side directly to the battery ground. That's has to be, it will be connected to the ground, but separately.
Good, papas? It's clear? No questions?
Do you need a galvanic isolator if you only have DC in your boat?
If you have AC.
No. Only AC.
AC. I have a small boat.
Yeah, I was gonna say, the only time you see galvanic ice is probably like 50 feet and up. I mean, on my end of the industry, I don't see the isolated transformer.
When you do your rewire job, you're not really messing with AC, right?
No, we do AC, but usually the boats are like well, like with that one Navro we did with the AC and the generator and all that, we didn't have an isolated transformer. It's only for big boats with a lot of
Yeah.
equipment.
It has in the book though, right?
Yeah?
It's in the book.
That would have to be a big sea rig.
The one with the stern drives that are not.
No, there's not. No, it has a generator and everything. It doesn't have isolated
Do
transformer.
they have a galvanic?
It doesn't even have isolated. Not every boat has it.
Yeah, I have.
You have it? You have the galvanic isolator?
You don't need that.
And a lot of our type of boats have the isolated transformer.
You know, on the boats that don't have the galvanic isolator, they have like water heaters, like the sea ray. The water heater just rot right out. It just eats it right out.
Okay, guys.
So, for the ground from the battery, you said will connect to the AC.
It will eventually, but not directly.
directly.
Right, it'll be like the bonding system is tied into the negative, but it's separate. It's nothing that you don't want going directly to the
Is there
battery.
an element that restricts the flow from the grounding bus bar to go back?
No.
Just naturally?
It's just, yeah, it's just, what happens is that you just don't want it, because if it's a major problem, it'll take the battery out and lose everything. If it takes it out, I mean, just take out the bus bar and that's it. Because, you know, the bus bars have certain amount of amperages you're allowed to use. So don't just buy any bus bar and assume it's gonna work for your application. You gotta make sure the amperage, it can withstand the amperage. You have some bus bars at 250 amps, 500 amps, and you have some that are 20 amps, 40 amps. You gotta make sure.
Okay,
Everybody just looks at it as a bus bar. Oh, it's a bus bar.
Yeah, so
No.
Guys, only to refresh quickly the topic about that one. That one. The topic about the bonding. Pay attention. This is a boat with the AC panel and DC panel. Follow me. Short power, generator, the switch selector, you remember? Main breaker, small breakers, neutral bus bar, negative, ground AC panel, AC bus bar, and the ground AC bus bar enter into the bonding conductor. This is the AC panel. We are going to check the DC panel. You remember? The positive coming entering the main breaker, small breaker, a negative bus bar, DC negative bus bar. The negative bus bar also connected with
the bonding system.
bonding conductor, and the bonding conductor externally connected with the sinks. It's clear? Right now this is the boat. I have AC panel, I have DC panel. This is a small boat because I have a single phase boat, no? It's a small boat like Danny said. All right. In that particular boat, I don't have a transformer, isolated transformer, but I have galvanic isolator to protect the intrusion of bad currents in my boat. Good? That's clear?
Yeah.
All right. What elements I am going to connect to the bonding system? The block of the engine connected to the bonding conductor. The fuel tank is in aluminum, connected to the bonding conductor. The transmission connected to the bonding. Yeah, all the metals in the boat shall be connected to the bonding conductor and to the zinc, because the zinc is the ground.
What is the bonding conductor?
It's located on the stringers. You remember? It's a piece of copper over there.
So like a big bus bar.
Yeah, it's a long. So in some cases they put these bus bars separated and connected with cable. That's the decision. That's your decision.
Is that copper epoxied into the?
Excuse me?
Is the copper epoxied into the fiberglass, or is it just?
Correct. In some cases, after the PP break, I am going to prepare a couple of pictures and I show to you. In the fiberglass on the stringers is laminated over there.
I've never seen it before.
No?
Yes.
I'm going to show. All right, that's good. You like it?
Yeah.
Great. That's bonding system. Okay. Turn off the.
Anything, even the appliances, everything.
Any through all. It's metallic bonding.
Anything with metal.
It's metallic.
What happens is, if you don't bond,
Oh, okay.
it'll start corroding.
141. That's correct.
Mine's a little bit older, yeah.
Yeah, you have that. Okay, great. Guys, let me explain something. You remember the previous picture on the screen? This is the bonding conductor, and the bonding conductor is connected externally with a wire with the piece of zinc. No? And look, the negative bus bar is connected with, and the ground bus bar in the AC panel to the bonding conductor. No? Bonding conductor. That's the bonding conductor, and the bonding conductor is located on the stringers.
Yeah, a high on the stringers. Put it in the
Correct.
water.
No, on the water. That's correct.
How do you attach?
With the
ground-
screws.
Screws. What screws?
Yeah, and every
Screws,
time you
and
listen,
top.
every time you put a screw in
yeah.
a stringer, make sure you seal it.
Yeah.
5200.
5200.
Well, I wouldn't use 5200 because if you have to replace it, you're gonna have fun taking it off.
Yeah.
Just use a good quality silicone
Okay.
for marine grade.
Okay,
Like
now
silica 295.
Yeah, you can use. I use. There's a, I forgot the name of the silicone. It's pretty hardy and it's pretty good. I mean, because once you put the bonding system, you're not gonna replace that bonding system unless it took out a lot of water. Like if your bilge pumps took a crap and the water filled up pretty high, now you gotta fix all the bonding system. You want that high. Huh?
Only use 5200, plan to never take it out again.
Let me tell you how strong 5200
Everything on the boat.
is. If anybody doesn't know what 5200 is, it's like
Okay.
super glue
So
of
it could be okay.
silicone. It's not silicone.
yeah, C-rate with a
So we
wire.
when we put swim platform brackets on back of boats to hang outboards, we use 5200 because I don't want it to come off. So this guy had a problem with his bracket after many years because he had electrolysis. And we went to take the bracket off. I couldn't get the damn bracket off. I took the motors, all the bolts out. And this was what, it was a Seamaster, big Seamaster, 29 foot. I can lift the whole boat from the platform with no bolts in the platform.
What?
And then when it finally let loose, because what I was doing is we grabbed both forklifts and we're just going bounce it up and down, and it ripped the gel coat right off the back of the boat. There's nothing you can do. I mean, it had to come off. But put it that way, 30-foot boat, I'm just lifting it with the swim platform. That's how strong that
Is
5200
that stripped or is that with everything?
Mickey Mouse technician.
What do you mean?
Is that like without
Mickey Mouse
console
Marina.
or does that have console?
Oh no, this had a big cabin in it, aft cabin, bath. It was a monster boat. I had to use 2 forklifts. Man, I used 1 forklift and I could barely lift the boat. I'm like, we grabbed the 2 forklifts. We just kept lift it up and I drop it down so it would like not all the way, but it would just go until it finally let loose. First I was jumping. I said, oh man, we get this thing. We put chisels and it would come off. 2 forklifts it took. That stuff is brutal. Now, if you're working with 5200 and you get it on you, you better use like CRC 656 or WD-40 to get it off your skin, because once that dries on you, you're gonna rip whatever hair. You're gonna be doing a personal wax.
Use mineral spirits. And make sure you wipe it right off, because
Right
once
off.
you get it on your hands, you get it somewhere on the boat.
Same thing in your sockets. If you're using a socket, you're putting your a motor on or something, you get 52 on, clean that right away. Now you have to get a razor blade and cut it off. Well, not even a razor blade, it's X-Acto knife. You get it off. Because if not, you won't be able to get it off.
I'll show you my socket. I got 5200.
You have it 200?
Why can't you use a power tool to get the
Fill it all the way up.
So what?
Why can't you use a power tool to just saw it off or something?
Well, then you cut the transom with the aluminum. But you think about it. If I cut the aluminum off, I'm not going to get it off. I'm going to have only that much aluminum left. So now you lost the leverage. Now you're trying to peel something off that small, because the bracket's about 2.5 feet out. I have leverage pulling on the outside. It's like using a wrench when you're trying to break something free. That's what they call breaker bars. The longer the breaker bar is, the more leverage you have. That's why it's important that if I cut it, then I would never get it off. Then I would have to literally chisel it out. By using that, I thought it was going to come off with one forklift, but it didn't. That was one extreme cases. So the 5200 is good for through holes, swim platforms, but like putting like on the deck or something, use a good silicone, because you're gonna eventually have to take it off.
All right. Okay, guys. Look, I am going to explain now one concept that is where the majority of the technicians make a lot of mistakes. It's the concept of reverse polarity. Reverse polarity. In the boats, in all the boats, if the panel is single phase, you have two LEDs. One LED green and one LED red. Red. The green when the shore power is connected and the switch selector is in shore power, should be on, indicating that you have power coming in. And basically this is an LED with two terminals. One terminal should be connected. One terminal should be connected to the negative bus bar, and the other one to the hot bus bar. That's okay? If you have power in the hot bus bar and in the neutral, the light should be on. Okay, pay attention. Suppose that the technician make a mistake and the technician connect here and here. What happened?
You talking about they reverse it?
What happened right now with this bar? This bar is
Neutral.
Positive.
is
Neutral.
neutral. It's not hot. And this one will be hot, no neutral, because I switch the cables. Yes or not?
Yes.
Oh, yeah. Look at this. You have another LED, the red one, normally connected with one leg with a resistor connected to the ground bus bar, and the other leg connected to the neutral. If the connection originally is good, this is hot and this is neutral, this light is off, because you don't have power here and you don't have power here. Yes or no?
Yes.
Okay, if you switch those cables, right now the hot excuse me, the neutral is hot. Sorry. The neutral is hot. I have hot and ground. I have voltage, no? You remember that when you read in between hot and ground, it's a little less, but it's voltage.
Yeah.
How is the light right now? On, because my neutral right now is hot. Okay. What is the function of the reverse polarity indicator? Reverse polarity indicator. What is the function?
Tell you that it's that does
indicate if the neutral bus bar is powered and the hot bus bar is neutral. Indicate a switch in between both phases. That's clear? Where is connected the reverse polarity indicator?
On the neutral.
One leg on the neutral bus bar and the other leg on ground to indicate if the hot and neutral are switches. Until that point is clear? That LED have a resistor here. The capacity of the resistor is 2.5 kilo ohms. ABYC question. It's an LED. It's a diode. Good?
That comes on the AC panel?
All the AC panels, single phase, they have the LED light for reverse polarity and the other LED for power.
181.
What do you guys think would be the effects
Yeah, in that-
of having
exactly.
reverse polarity?
So that-
Exactly. And this
Knowing
is
what you know
and this is
now,
the connection.
What would be the damage you would cause?
It says 2.5. Oh, is that?
Yeah, it's
Huh?
exactly 2.5.
You know, short circuit?
It's 25
Now,
kilo ohms.
Okay.
Sorry.
what's connected to the neutral at the source? Ground. So now, if I had a reverse polarity, you just energize your bonding system.
Okay, yeah. That's the next. That's the next. Pay attention. I said neutral and ground should be connected together only
At the source.
at the source of the power. After that, they are separated. Neutral here, ground here. Neutral bus bar, ground bus. No, the bars are close but not connected. In normal condition, if my boat is properly wired, if I try to read voltage in between the ground bus bar and the neutral bus bar, how much is the voltage? 0. No? All right. Okay, pay attention. Look at this. Guys, in this moment, the ground bus bar is connected with the bonding. You remember what is the enemy when you have two dissimilar metals together in contact with water? The galvanic corrosion is accelerated. If additionally in between both metals I have a leak of current, the arc of current in between both metals accelerate the corrosion, and the more noble attack the less noble and erode the less noble. That's clear, no? Okay, look at this. Now I am in the situation that I have the reverse polarity on. Why?
Because your neutral is on.
Because the neutral enter in the hot and the hot enter in the neutral. I switch those cables, correct?
Yeah.
All right, now my neutral is hot. And yesterday, my wife invited one Mickey Mouse technician to install a fan in my boat. And that guy is residential electrician. They say that neutral and ground is the same. And that guy put together the neutral and the ground bus bar. That guy connect together this with this because they say that is the same. And now the both have reverse polarity. This one is hot. If this is hot right now, this is hot. And I have 120 volts in the bonding. What happened with the through holes in 2 days?
corrosion.
No, perforated and the boat sink. Finito.
They fall out.
Finito, you destroyed your boat. Not in your case because you're through.
Ours is a little different. Ours is a little different.
But it's not good.
But it's not good.
It's not good. Now you understand? Reverse polarity?
Yeah.
And why reverse polarity is catastrophic? You understand, guys? It's because the ground right now will be hot. And the ground is connected with the bonding. And I have a lot of metallic elements connected to the bonding. And those metallic elements right now receive 120. Wow.
One thing you gotta think about, if you electrify, your gas tank is bonded to
Your gas tank is bonded with 120.
You have 120 volts with a full 100-gallon fuel tank. It's a ticking time bomb.
Danny, and suppose that Yesterday, other Mickey Mouse technician decided install the bilge pump.
Gotta make sure you say.
The bilge pump, the negative of the bilge pump. Oh, that metallic conductor. Oh, it's ground. Nice, I have ground here. Positive bilge pump connected, and suddenly I have reverse polarity. I have 120 in the negative. What happened with the bilge pump?
Boom. All right.
Kaboom.
Being in this field, you're gonna run into, like you said, the Mickey Mouse technicians. You guys will be able to differentiate what's right or wrong. I'm gonna just give you an example. This is before ABYC. Someone made a fuel tank and made a aluminum channel to run all the battery cables, all the stuff in there. So when I got in there, he was having some electrical problems. So I went in the boat, I'm like chasing him, man, something's not right. We opened the hatch, the floor, I couldn't access it. It was an old Panga. And what happens is when the wire was running in through the channel, no one wrapped the wires. So think about it, when you're driving the boat, vibration, aluminum on the wires, with time, can't do stuff like that. But you didn't have ABYC. This is going back, way back. But now you guys are still gonna run into that because you're gonna run into old boats that are still around, or you have some guy that still thinks like that, and you're gonna run into it. Cameron went to my show. You seen all those the house wires on that one boat? Yeah, man. That guy, because he's an electrician. You know who's an electrician and who's not. When you see wire nuts, the wire nuts that you see in the house, that guy's more likely an electrician or a handyman. You don't want that because it's an axis of corrosion. It doesn't protect the wire. The heat shrink, there's a reason why we have heat shrink. Remember, you're in the most corrosive environment that you could possibly be, is the ocean. Florida, actually. Anything by the ocean is corrosive. So by protecting it. Because it'll work for you, but it won't last. And then the guy's gonna go and he's gonna say, man, I just paid this guy X amount of dollars and it only lasted me a month. He's gonna call you back?
No.
Yeah, maybe once.
He'll call you back. That's why you do it right. You only want to do it one time. At least you try to.
Sometimes it doesn't ran into yesterday in my house.
That's
See
the
that?
ground.
Yeah.
That's the ground.
That's the power for the whole house.
Oh, really?
Yeah,
Yeah,
just put a
sorry,
huge ball
sorry.
together.
Yeah, the power.
That's it.
Where? Where do you live?
No, this is the lighthouse point. The
Ah.
lighthouse point.
This is the power.
It's a very old house.
All right. Was clear the reverse polarity? Okay, good. Now I am going to replace, we are going to continue with single phase. I am going to replace the switch selector, the traditional switch selector, for three breakers. Ready? Because this one is too expensive and it's not easy, the connection. You can make a lot of mistakes here.
Not only that, one side goes bad, you gotta replace the whole thing here.
Yeah.
You can just cheaply replace just the breaker. I like the breaker system.
The breaker is nice because you select the breaker that you
In
prefer.
most AC panels, when they have the breakers, there's like a little slide that goes over like the shore power, so you can't turn both things on at the same time.
Okay, I am going to connect at the input of each breaker, the input of each power. Okay, this is the power coming from? Shore. This is the shore breaker. Shore breaker. And this is the power coming from?
Generator, yes.
The second one here. The second one here is inverter, no?
Yeah.
Inverter. And I am going to bring the power for inverter here. That's correct?
Yes.
And in this one, I am going to connect the power for generator. Perfect. Until this point, no problem. I have three powers, pin. In the output, I am going to connect together the output of this with the output of this and the output of this. And the neutrals connected together. And now I have only one hot here and only one neutral here. Now you understand? Pay attention. This is off, and this is on. Ah, okay, only that power goes into the transformer and feed the panel. Oh, now this is off, off, and this is on. Only that power goes here and enter in the panel. Oh, this is off, 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 and this is on. Only this power enter over there. Good? How you protect that? You remember in those both you have a slide bar, metallic bar, that is metallic, and you move the bar and you block the other two breakers. That's too simple. In this moment, this and this is blocked. You only have access to this. Ready?
Because let's say theoretically you were to turn on two at the same time. What would
It's not possible because the bar only allow to turn on one breaker.
Yeah, but let's say it would explode the boat?
No.
No?
No explode, but you can damage. No, explode the boat. All right. Ah, sorry. I mean,
So what is the,
reverse polarity. Hialeah definition.
When that happens, what happens? You supply too much like voltage or something, and it just breaks that.
When you have reverse polarity?
No, when like you said, if you switch more than one on.
No. You overheat the wires. That's the problem. That's the problem. But if you have, for example, if you have this and this together, probably you send power into the inverter and you damage the inverter. You send power from coming in through the output and you damage the circuit board. Or vice versa. If the generator is off and you have this and this on, you send double power through those cables and you damage the winding of the stator. That's not good. Alright? Okay, great?
Yep.
You move that one and you select only one. You like the procedure to connect with 3 breakers? Yeah. Difficult?
No.
This is the project that we are going to do on the lab. That project, that's the project.
I just want to put one picture up so you can see. I just want you guys to
Excuse
see
me, which one? Oh, that one. For the,
what happens when we don't have a box system.
oh, perfect.
So you have some keynotes there. You have some keynotes.
Yeah, this is a, no, la dejo. Mira, look at this.
That's by the streamer.
Look at this picture.
so you can have it for next.
You see, this is reverse polarity. This is a reverse polarity issue, and those terminals.
That's for your strut.
Some of them, they should be connected to the bonding. They are receiving constantly 120 volts. This is catastrophic in a boat. Reverse polarity in a boat is catastrophic. You need to be careful with that.
How many times have you run into boat lengths?
Dolphins really do wire
Reverse polarity.
For what?
Like, have you seen it? Reverse polarity is usually done by someone.
Yeah.
It's not something that just happens.
Right.
Someone was working on something.
Sometimes it happens with just a short power cable.
You understand, sometimes these panels, man, whoever did the panels, when you make panels, you should make the wires long enough so when you take the panel, you can see it. Some people make them so short that you can only see so much, so it's very easy to make a mistake. That's why I like making my wires longer in the panels, even though I have to tuck the wire. But then when I take the panel out, I can put it literally almost in front of me and I can see everything and it's easier.
The idea
Instead of
is-
you going like this and trying to change a wire like that. You know, and also when you work on AC power, turn off the AC system.
If you have your AC panel rigged right with just a light bulb, rigged reverse part, with the whole system,
If you have it rigged right, the reverse polarity won't turn on.
just,
It won't even turn on. It only turns on when the reverse polarity.
well, what if you just have just a light bulb on the panel?
Oh, they install, well, the only way, just how he said, check your neutral to ground, see if you have power. That's all. The multi, you can go right behind the panel, go right to the neutral and ground,
But what if-
and you've got 120 volts, even though the light bulb's not working, because sometimes those light bulbs burn out, you gotta realize. If you come to, see, the problem is if the light bulb's burned out, you're not gonna know. And the guy's having, because the first sign of the earthquake is corrosion will be intensified. There's a lot of corrosion. First thing I would do is take the panel out, check the neutral and ground, and make sure that I don't have power. If I have power there, then you know the motor's like that. Then I would tell the guy, hey, we gotta fix this, and we're changing that bulb.
With that one light bulb, you do damage to the whole building?
No, the light bulb's not, it's only 2.5 ohms. Yeah, it's a little bit.
I'm pretty sure you're not supposed to. You can't protest AC, can you?
No, well, you know, protester supposedly has an AC thing. I don't know. I don't think I would use a protester on the AC side. On the DC side, without a doubt. The AC side, I know they have it. They even have now. I think they even have some like little oscilloscope that you're talking like $500-$600 for. And the way I go through power probes, you don't want to buy the expensive.
Why do you go to power? You break it?
You know, when you're in the bilge and you're in a small hole, sometimes that thing goes right in the bilge in the water. You know, actually it happens quite a bit.
The new Power Probe has a whole frequency meter and everything.
Yeah, I know, but it's like $300-$400 for that. The one from Amazon is $160, and if $160 is still a lot to just throw away, but I mean it's better than $400. That shoots up with $400. Huh?
Snap-on, no replacement for it.
Okay, guys.
Oh yeah, even if it goes in the water?
Follow me because we don't have too much time. Good. We are going to connect the battery charger. Where is coming the power in into the battery charger? The power in is AC power. And the power out is DC to charge the battery bank, no? Okay. The power in is coming from
Isolator.
the AC panel. Doesn't matter if the AC panel in that moment is powered from generator or inverter or shore power. It's AC power. Okay, I have one breaker here. The breaker is battery charger.
You cut, because usually the battery chargers come with the prongs, no, that you put in the outlet.
Excuse me?
Usually the battery chargers come with like the ones that
Exactly. You plug it over there.
Yeah. So what? You cut the wires to connect it to your AC panel?
Correct. You don't have a plug. You have the cables, hot, neutral, and ground, and go directly into the panel. And one breaker will be for battery charger. That's clear?
Yes.
We are going to do that connection. We are going to cut it, the plug, and you split the cables and you connect in the panel. Okay. One cable is for hot. Other cable is for neutral. And other cable is for look at this, front, the case. And now I have one positive here for this, and other positive here for the other battery bank. Ready? And the negative here for negative. Great? This is the battery charger. This is the input of the battery charger. This is the input, AC power, and this is the output DC power. Good?
You should never put your battery charger positive into a common, right?
No.
Directly to the batteries?
No, of course. Here, those positives enter in the ACR and the ACR and the but I don't put ACR.